All right, so part B says to calculate the displacement during the following time intervals. Displacement from a velocity time graph. How do we do that? We have to use our area formulas. Okay, so we have to split up the area underneath the graph into shapes like triangles, which have an area that we can calculate by using the formula base times height divided by 2. And we can also split up the areas into rectangles sometimes, and so we'll use the formula base times height. Okay, so let's split up our area underneath the graph and then work out the areas, and then we can answer the questions. All right, so first area is going to be this rectangle, this triangle right here. I'm going to call that 1 second. It's going to be this rectangle here. Okay, I'm going to call that 2. Then this triangle here, call that 3, and then this area right here, we'll call that 4. Okay, so part A says calculate the displacement during the times 0 to 6 seconds. All right, so we're looking for the shapes that fall under the graph between 0 and 6 seconds. So that's right here. So that's 1 and 2. So we have to find the area of the triangle plus the area of the rectangle. And then we would add them together, and that would give us our displacement. So the area of the triangle we find by multiplying base times height over 2. The base of the triangle is actually the time taken, so that's 3 seconds. The height is actually the velocity, so that's 6. And then divide by 2. So 3 times 6, that's 18 over 2, so that's 9 meters traveled during that section. And then second part, the area of the rectangle is just going to be base times height. The base, in this case, that's 6 minus 3, that's 3. Multiplied by the height, which is also 6, so 3 times 6. So that is 18 meters. Okay, so the total displacement traveled between 0 and 6 seconds is going to be 9 plus 18, which is going to give us, right, 27 meters. All right, second part, we want to know the displacement between 0 and 9 seconds. Well, we already found the displacement between 0 and 6 seconds, so we just need to calculate the area of this section up to the 9-second mark, and then we add that to the previous answer. So area between the area of the triangle plus the rectangle, which is 0 to 6 seconds, we know is 27 meters plus area of this triangle here, okay, base times height over 2. The base is 9 minus 6, which is 3, multiplied by the height, which is 6, all over 2, which is 9 meters. And we're going to add that to the 27 meters that was already traveled, and that's going to give us a total of 36 meters. Okay. And finally, we want to add the displacement traveled, but remember, displacement is a vector, so when the velocity is decreasing, okay, that means that this is slowing down. So the distance traveled, or the displacement underneath the graph, is actually in the opposite direction. So it's like the student turned around and is going back to where it started from. So it's walking backwards, so we're actually going to subtract. If you were to calculate the entire displacement for the whole journey, you would subtract what's below the graph, so below the 0 line, in order to get the total displacement. So this is the forward motion at the top, and this is the backward motion at the bottom. Okay, so we're going to calculate we're calculating the entire thing now. So what we're going to have to do is first find out what was the backward displacement, so this area, and then we're going to subtract that from our forward displacement, which is between 0 and 9 seconds, that entire top part. Okay, so backward displacement, that's this area right here, area of that triangle, base times height over 2, base of 3, height of -6. Okay, so we're going to be looking at depth this time because it's increasing in this way. So divide that by 2, and what we're going to get is a -9. Okay, and so the total displacement is going to be this here, from 0 to 12 seconds. That's the total displacement. And so we're going to subtract the forward displacement, it's in the positive direction, subtract this 9 meters from that. Okay, I only put the negative here just to show that this is backward, but you're not going to carry that in there. Okay, we're going to subtract the forward from the backward, and that's going to give us 27 meters. So total displacement from the starting point would be 27 meters. Okay, 27, 36, 27. All right. So the next part number 3, we have a graph that shows the motion of part of a car journey, and we want to look at the segments of the graph. So AB, that's a segment, BC, that's a segment, CD, that's a segment, DE, that's a segment. And we want to know in which segment is the car accelerating at the greatest rate. Okay, now this one, if you said AB or DE, I would give you the point, because this question should have really asked, if the answer was to be exclusively AB, it should have said uniformly. Okay, because this is uniform acceleration. This is also accelerating because the speed is changing, the velocity is changing, it's increasing, but it's not increasing uniformly. So this is non-uniform acceleration. Okay, and in order to find out what the acceleration is here, we would have to take the slope of a tangent to this line, and that part looks steeper than that part, so definitively we can't really say. So if you said AB or DE, then I'll give you the point. Okay. Second part, the car is traveling at a steady speed. There's only one answer for that. Steady speed means that flat horizontal line. So that's segment BC. The acceleration of the car is getting bigger and bigger. Okay. So that means not steady. That means it keeps increasing. That's this segment here, DE. Okay. Last section, we want to use this distance time graph to describe the motion of a dog walking along this path, and we want to look at several sections on his journey. So what is the motion of the dog between B and C? So remember that distance time graphs tell us about the speed, and so we can see that he's moving at a constant speed, but he is actually slowing. Right, so the slope is negative here, so he's actually walking backwards. Okay, so we're gonna put constant speed because the line is straight and not curved, and then we can put backwards. Constant speed is sufficient, but in case you're asked. Okay, between F and G, that's this section right here, the line is flat. Okay, and what that means is he came back to where he started from. The line is flat, so he is at rest or not moving. Okay, this is the one that you'd want to say on the test. That's what you want to say on the test. Okay, and finally, what is the velocity of the dog between D and E? So we have to calculate the slope for this section DE. Okay, so similar to the acceleration formula, V2 minus V1, you're going to do velocity is equal to D2 minus D1 over T2 minus T1. So let's find our values. This is our point 1, this is our point 2. The distance at point 1 is, let's fill in these numbers. These are counting in 2, so that's 0, 2, 4, 6, 8. Okay, so that's 8 meters for D2. D1 sorry, this is D2, and D2 is 12 meters. Let's fix that. D1 is 8 meters. Okay, so 12 minus 8 over T2, point 2, come down. These are counting in 1, so that's 1, 2, 3, 4, 5, 6, 7, 9, 11, and 13. So come down. T2 is 13, and T1 is 10. So 12 minus 8 is going to give us 4 over 13 minus 10, which is going to give us 3. So we can leave that as a fraction, or we can simplify it. Probably want to simplify it. And that's going to give us 1.33. Don't be scared by the decimals. Decimals are numbers too. And that is meters per second. All right, that's it. Let me know if you guys have any questions.